So I think we're down to the last one, unless I've forgotten one. And the last one is the binary outcome, my COPD. So I'm going to create my COPD variable, and this one is going to be a little bit more complex. So I just want to go over my strategy before I start writing the code. Now, I'm going to be using a definition of COPD that if someone says they had bronchitis or emphysema, or they had an FEV1 to FVC ratio less than 70%, or they were in the lower limit of normal for FEV1 to FVC for their age group, so if any of these are true, well, actually, if they have bronchitis or emphysema, they will definitely have COPD. But if they had an FEV1 to FVC ratio less than 70%, or they were within the lower limit of normal for their age range, they were sent for a second spirometry test in the NHANES protocol. And they first gave them a bronchodilator and then tested their spirometry again. Now, the purpose of this is to distinguish between COPD and asthma. For asthma, if you take a bronchodilator, then that's going to relieve your airway constriction, whereas for COPD, that's not going to be true. Of course, that's not going to be completely true for all people. There's some overlap between the two conditions, but I'm going to use that as my definition. So essentially, if someone had a low FEV1 to FVC ratio and was sent for the second test, if after the bronchodilator their FEV1 to FVC ratio improved at all, I'm going to consider them to have asthma rather than COPD. So what I should say here is that for this group, it's if you have either of these and you had no improvement after bronchodilator. So this is going to be my definition of COPD. Now my strategy here is I'm going to have the working data. This is the work data. And some portion of this work data were going to be sent for the second spirometry test, and I have a variable that indicates whether or not that was true. So what I'm going to do is I'm going to create a subset of the data, and then I'm going to check for whether or not the bronchodilator improved or not, and then we'll decide within this section who has COPD or not among those who went through this second spirometry test. And then once I decide the COPD here, I will link that back to the original data set. Now for bronchitis and emphysema, I can just use these criteria through the entire data set. And anybody who has bronchitis or emphysema, in fact, if anyone had ever had a history of bronchitis or emphysema, we're going to include them in the COPD group here. Okay, so let's get started on this one. So I will do data, work data, set, work data. And let's start with the bronchitis and emphysema variables. So let's look at the first one. For bronchitis, what is the variable? Let's see, where is it? Ah, there it is. So have you ever been told that you have chronic bronchitis? So I'm going to use this variable. And it looks like number 7 is refused and number 9 is don't know. So the first thing I'm going to do is I'm going to recode that to those to a dot. So if this variable is in 7 or 9, then that variable equals a missing value. And then that's the bronchitis one. The one for emphysema is down here. Have you ever been told that you have emphysema? It's also 7 is refused, 9 is don't know. So I'm going to say if the emphysema variable is in 7 or 9, then the emphysema variable is going to equal missing. So these variables are hard to remember. So I'm going to give them a name, a different name. And I'm also going to see if maybe I want to recode them. So for this one, both of them are coded 1 for yes, 2 for no. So I think what I'm going to do is I'm going to code them 1 and 0, just because it's easier for me to remember that. And so what I'm going to do is I'm going to say if, let's start with the bronchitis variable. 160K was bronchitis, right? Yes. So I'm going to say if this variable equals 1, which is yes, then I'm going to create a new variable, bronchitis equals 1, which is yes. And if that variable equals 2, then bronchitis is going to equal 0. And I'm going to do the same thing here for emphysema. So it's going to be this variable. If that variable equals 1, then emphysema equals 1. And then if that variable equals 2, emphysema is going to equal 0. Now let me do a proc frequency just to make sure that I got everything done correctly. And what I'm going to do is first I'm going to look at this one crossed with bronchitis. And then I'm going to look at this one crossed with emphysema. And I'm going to use /list. And I'll run it. Now let's see what happens when we run this. Okay, so it looks like the coding was done correctly. We have some missing. We have very few missing for bronchitis and emphysema. And so we have about what? We have about 6% with bronchitis and about 2% with emphysema. So I'm just going to comment these things out. And we're going to use this down here. So actually I'm going to leave this run up here because now what I'm going to do is I'm going to create a smaller data set, a subset of the data that only includes those people who had the second bronchodilator test. So I don't want to overwrite the data in work data. So I'm going to create a new data set in the working memory. And let's just call it COPD because we're looking for COPD. And I'm going to use what's in work data, read it into the memory again, and now give it a different label, COPD. So now I'm going to have two different working data sets going in the working memory. One is pointed to by the label work data. This one is going to be pointed to by the label COPD. And for this one, I want to limit it to those people who had the second bronchodilator test. And there should be a variable in here that tells us that. There it is right there. So it's SPD bronch. It's being selected for the bronchodilator. These are the people who had an FEV1 to FVC ratio that was less than 70%, or they were below the lower limit of normal for their age. So I'm going to say if bronchodilator, and what was it if they were selected? The value is equal to 1. So if that equals 1, now let's just run it and let's see how many we get here. Look in the log file. So there were 1,500 approximately who were sent for the second bronchodilator. That seems reasonable. And then, so what I want to do first is I want to calculate the initial FEV1 to FVC ratio, because for these people, what I'm going to be doing is I'm going to be comparing the first and second FEV1 to FVC ratio values. Now, we've already done this once before up top, so I can actually just copy this code. So this will give me the FEV1 to FVC ratio inside this COPD data set. Now this actually is already in there because we calculated it above for the working data, and I have read the working data into the COPD, but I'm going to go ahead and redo this here. And the reason I'm doing that is so that later, if I come and I run the code, just this section, the section will run by itself. It won't depend upon me having to run this section first. So I'm being a little bit redundant here, but it's just to make the code, each section self-sufficient. So this is the first FEV1 to FVC ratio. And so now what I have to do is I need to calculate the second one. And so these variables are in the code book here. And we have another quality variable, which is coded the same way as the first FEV1 to FVC ratio quality variable. And so I'm going to use this one, and I'm going to do the same kind of thing that I did before here, except I'm going to be using this variable. So it looks like what happens is that the N gets changed to B. Let's see if that's the same thing that happens for the other one. This is FEV1, and let's see, where's the FVC? Oh, it's right here. So this one also, the N gets changed to a B. So I can just copy and paste and change that N to a B. So this N gets changed to a B. This N gets changed to a B. And then are these also N to B? Let's see the values themselves. Second FEV1, N goes to a B. Yep, so it looks like that's what's going to happen. So this N becomes a B. And this is the second FEV1 to FVC, so I'm just going to add a 2 to it. These are going to be calculated with these values, which are the B's. And it's only going to be calculated if they have a good quality FEV1 and FVC value. So let's go ahead and do that. See how it goes here. Look at the log file. Looks all blue. We have some missing values generated, but that's expected because we're going to have some missing values in here for those people who didn't have a good quality measure. And so now we have this. So then what I can do is I can find out if the FEV1 to FVC ratio improved after the bronchodilator in the second FEV1 to FVC ratio test. And so what I'm going to say is I'm going to call this percent. I'm just going to call this, let's see, this is FEV1 to ratio. It's a change in the ratio. So I'm just going to call this change FEV1 to FVC. How about that? And so then what I'm going to do is it's going to be the second value minus the first value. And if it improves, then it's going to be a positive number. Otherwise, it's no improvement. So let's just do a quick look here to see what they look like. Not proc frequency. I want to do a proc univariate variable, and I'm going to calculate, or I'm going to look at this one. And I'm going to do a histogram and a run. So let's just see what we get here. See how this looks. Oh, something crashed. What did I do wrong? Proc unvariate not found. Not unvariate, it's univariate. All right. Okay, there we go. So look at that. The change in the FEV1 to FVC ratio is kind of normal distribution. Looks like the mean is around 4% increase. So I'm going to cut it off here at 0. So basically anybody who had an improvement in their FEV1 to FVC ratio, we're going to assume that they have asthma and not COPD. So it's going to be this group down here. So what I want to do now is I want to create a COPD variable, and I'm going to call this COPD FEV1 FVC. So this means this is your COPD calculated from your FEV1 to FVC ratio. And how are we going to calculate it? So it's going to be if the change in the FEV1 to FVC ratio is greater than 0, then the COPD by this is going to be 0. It means you don't have COPD if you had an improvement in your FEV1 to FVC ratio after the bronchodilator test. And I'm going to say if the change in the FEV1 to FVC ratio is less than or equal to 0, then this is going to be equal to 1. Now, one of the problems here, one thing you should be aware of is that missing values are actually considered to be less than 0. So this is actually going to say if the change is missing, it's going to be true because missing is less than 0. So I need to put one more line in here just to take out those missing values. So if the FEV1 to FVC ratio is missing, then I'm going to say that this value is also missing. So let's try this and let's see what we get. So let's do a proc frequency tables. Let's just see how many people we have with COPD. Okay, let's expand this and run it. See what we get here. Okay, so we have 11% out of this group, the subgroup, that has COPD. So that seems about right. So now what we can do is let's comment out these things. Now what I want to do next is I want to merge these data back with the original work data. But the only thing I want here is I want the COPD by FEV1 to FVC. So I'm going to do a keep statement here. I want to keep the sequence and I want to keep my new variable, which is COPD FEV1 to FVC ratio. And I need to sort the data before I can merge them. And I actually need to sort these data up here as well, the working data. So let me put a sort in here, proc sort by sequence. And I'm going to merge these work data with these COPD data, but let's do this first. Make sure everything runs okay. That looks okay. And then let's do the merge. So data, work data, merge work data, COPD by SEQN. Run it. Let's see how it goes here. So we had 10,989 initially, and then we have 1488. So that's about right. Okay, so this looks fine. So now what I can do is I can calculate my COPD using my three variables, bronchitis, emphysema, and then COPD by the FEV1 to FVC ratio. So I can actually do this within this data set statement. So what am I going to do? So if COPD is going to be, it's going to be COPD if they have any of emphysema, bronchitis, or the COPD. So what I can do is I can say if, let's go up here, bronchitis equals 1, or emphysema equals 1, or the COPD by the FEV1 to FVC ratio equals 1, then what I'm going to do is I'm going to say COPD is going to be my COPD variable is equal to 1. Okay, so if you have any of those, then you have COPD. These OR statements, we haven't seen these before. This is a normal if-then clause. If-then, and it checks the thing between the if and then to see if it's true. Now, this is true if any one of these three things is true, if the bronchitis equals 1, or the emphysema equals 1, or the COPD by the FEV1 to FVC ratio is equal to 1, we could also put parentheses around this to make it really clear that it's a single logical unit. Why don't we just go ahead and do that? It's not necessary here because it's not ambiguous. So what I'm going to do here is I'm going to say if you don't have COPD, if none of these is true, then I'm going to say COPD equals 0. So I'm going to use the else here. So if this is true, then COPD equals 1. Otherwise, COPD equals 0. So there's one problem with this, the way that I've done this. So think, for example, if bronchitis equaled missing and emphysema equaled 0 and the COPD by the FEV1 to FVC ratio equals 0, well, this person is going to be coded as not having COPD. But the problem is that bronchitis, because it's missing, we don't actually know if they don't have COPD. This might be equal to 1, in which case they should be coded COPD. So for somebody like this, we really shouldn't code them as 0. We should code their COPD value as missing because we don't have enough data to do it. Now, it's different up here. If we have some missing values, as long as one of these is equal to 1, it doesn't matter what the values on the other variables are. So it's okay to go ahead and code that as a 1. So we really only have to worry about these zeros if there's missing data. So I'm going to put another line in here to have the SAS go back through all of the rows one by one. Because remember, it does one line for every row, and then it goes then the next line of code and does it for every row. So we can go back and we can rewrite some of these COPD equals zeros if we have missing data. So what I'm going to say is if bronchitis is missing, or emphysema is missing, or now here what I want is I want to know, if people didn't have the initial FEV1 to FVC ratio, that they didn't do the first spirometry test. And so what I'm going to do is I'm going to use this value up here. So the first spirometry test, this is the FVC ratio. If this is missing, or this is missing, so if any of these are missing, and we said here that their COPD is equal to 0, what I want to do then is I want to call that COPD as missing. So this means that if I coded them as COPD equals 0, but they have something missing here, it means I don't have enough information to actually code them as COPD equals 0 as no, and so I'm going to recode that as missing. So let's do a proc frequency to find out what the final prevalence of COPD is in this data set. So I got a prevalence of COPD of about 10% in the population, and that's consistent with what I had seen in the literature. But notice that there's a lot of people with missing data, 27 to 75. Of course, these are people who went to the mobile examination center, so I lost some people because of that. That's actually okay because we have ways of controlling for that. But we're also missing probably some more who just didn't do the spirometry test, or they didn't do it well enough, or they... and so we've got about, what? Hard to say how many we've got here. We've probably got about 20% maybe who are missing this. So it's quite a high level of missing. And so there's more of a danger here of selection bias. So we'll just have to discuss that when we get to the interpretation of the model. Okay, so let me just comment out these. So I just want to see if this entire thing will run from beginning to end. So let me clear the log file. And I'm going to run the entire thing. Okay, it's all done. Now let's just see how it's doing here. So it looks like it is doing everything okay. It's missing values, we saw that before. Okay, I think that's the writing to the hard drive. So I think that it should be fine, actually. So the last step here is that we want to write these data to the hard drive. And I actually have the code in here from before. So it just wrote the data to the hard drive. So I'm done now. I can save this. This will work. And so now I can create my working data. This brings the raw data, merges it together. That's what we did before. And now I have recoded and cleaned all of my variables. And so this is one step closer to being ready to start building the models themselves. So hopefully you can follow the example of this and be able to figure out how to clean and recode your own variables for your model. And if you have trouble, if you run into questions that you're unable to figure out, just contact me and we will figure it out together. So the last thing we need to do here is just to update our shorthand version for our models, incorporating the decisions that we made about the continuous variables. So I decided for the smoking variable that I was going to use a continuous measure. And for age and income, let me just make some more space here. For age, I decided to use continuous, and for income, I used categorical. And the same was true for the other model. So this is the final shorthand version of my two models, and now I have all of my variables recoded and ready to go for the next step in the model building process. So this is what I hope you can get to at the next step in building your own models.